Today's topic is functions. After successfully completing this topic, the students will be able to know what a function is, type of functions, graphical presentation of functions. Definition of function. How you will define the function. Given any two sets A and B, a function f from A to B, or you can say it as mapping, f from A to B is a rule which assigns exactly one element fx belongs to B to each element x belongs to A. So A is what this A is set. This set A is set to domain of the function f. B is said to be the codomain of function f. And this small b, or if I write this the function f from A to B as f of A is equal to B, then B is called the image of A under f. A is called the pre-image of B under F. In this way, we can define these as domain, codomain, image, and pre-image under F. Now I have two sets as R and Z, where R is said to be domain of the function, Z is said to be codomain of the function, F is a rule from R to Z. Say if I have the point 4.3, then f of 4.3, this will be 4, where 4.3 lies in the domain set, and f of 4.3, image of 4.3 is 4. Also 4.3 is said to be pre-image of 4, whereas 4 is said to be image of 4.3. Now if our domain is a real number, range is a real number, then f is said to be real valued function. So mainly we will deal with real valued functions. Graphical presentation, how you will express functions graphically. So we can express them graphically in three ways. First is Venn diagram, another is graph, another is plot. So in Venn diagram you can see that A and B are two sets, and small a is an element belongs to A, and image of f of A is B. So B is equal to f of A, where B is an element lying in the set B. Similarly, we can represent them graphically or through the plotting. By taking various values of x, we will get various values of y. Then we join those points, that will give you a curve. So in this way, we can present the functions. For example, if I have the function y is equal to 2x, now I will take various values of x. Corresponding to various values of x, I will get various values of y. Say if x is 0, then y will be 2 into 0, which is equal to 0. If x is minus 1, then minus 1 multiplied 2 is minus 2, so y is minus 2. Again, when x is minus 2, y is minus 4. If x is 1, y is 2. If x is 2, y is 4. So in this way we can make xy chart. Now how you will represent in mapping? In mapping, now the entries of A are set to be input, and entries of Y, they are set to be output, and minus 2 corresponds to minus 4, minus 1 corresponds to minus 2, and so on. 2 corresponds to 4. It is a function. Next you have properties of functions. So first property is even functions. The function is said to be even if it has symmetry about y-axis. You can see that this is the curve. It is symmetrical about this y-axis, this part. Clear? Next, even function can be defined as f of minus x is equal to fx. For example, fx is equal to x square. So for an even function, For every xy on the graph, the point minus x minus y is also on the graph. Functions. Odd functions, they have symmetry about the origin. As you can see in the graph in xy plane, this is symmetrical in the graph which lie in minus x minus y plane. Also, the odd function satisfies the property f of minus x. This will be equal to minus fx. Say if my x is x cube, then f of minus x cube, this will give me minus of fx. Clear? So in this type of functions are said to be odd functions. Next is type of functions. First is one-one function. If function is one-to-one or injective or an injection, if every element of its range has only one pre-image. So if every element of range has only one pre-image, then that set is said to be one-one set, one-one function. Next is how you will show these. So with the help of diagram I can show this, that each range element, first 4 and 5, first 2 4 and 5, this set is the set of range. Now each element has its pre-image, so it is one function. But here what is going on, this entry 2 has two pre-images, so it is not a one-to-one function. Next is onto function. A function f from a to b is onto or surjective or a surjection if and only if range is equal to its codomain. Means whatever the range of the set of the function is, this range is equal to set of codomain. That is, for all b belongs to b, there exists a belongs to a such that f of a is equal to b. For example, x cube is onto. So some functions that are or not onto are shown as. Now this function first is onto function, second is onto function, and this function is one and onto both, because each element has its pre-image and range set, this is equal to the set of codomain, so it is one and onto both. Next is linear functions. How will you define a linear function? Now a linear function is defined as. How will you define a constant function? So if fx is equal to b, where b is any real, domain of these functions, constant functions, is all real number and range will be b only. So you can see that f of minus 1, a red line, it is the example of a constant function. Value of the functions remains constant throughout the interval. Now similarly, I have the function fx is equal to 1. Again, it is shown by green line because value of the function remains same throughout the interval. Again, I have the function fx is equal to 3. It is parallel to x-axis. So in this way, I can define a constant function. Next is identity function. A function fx is equal to x is said to be identity function. Now if I draw the figure of fx is equal to x, I will find a line which is inclined at an angle of 45 degree and passing through the origin. Now for this function fx is equal to x, slope is 1, because if you compare it with mx plus c, here m is 1 and c y-intercept is 0. So domain of this function is all real numbers. Range is also all real numbers. Next is square function. how will you define a square function? If your function fx this is equal to x square, or you can say fx is equal to y, say y is equal to x square, it will be a upward parabola. If you take various points of x corresponding to various points of x, you are getting fx. When you join these points, you will get an upper parabola or parabola in the upward direction. Now domain of this function is all real line and range is all non-negative real numbers. Now check whether this square function is a even function or odd function or neither even nor odd. You can see that if I replace x with minus x, I am again getting x square. So it's a square function. Square function is next is square root function. Square root function fx is defined as fx is equal to root of x, and it will be a half parabola toward x-axis. It will be a half parabola towards x-axis. Now domain of this function is non-negative real numbers and range is non-negative real numbers. So domain and range for this square root function are the same. Next I have rational function. A function qx which is of the form qx is equal to fx by gx, where fx and gx are polynomial functions and domain of qx is the set of all real numbers such that gx is non-zero, is called a rational function. For example, you have x plus 1 upon x cube. It is an example of a rational function. That's all. Thank you.